All right. Hello, everyone. Hi, welcome to today's meetup. My name is Dalia and I work on Elastic's community team. Today, we're here to hear from Alessandro, and he's going to talk to us about time series data with Index Lifecycle Management feature. Let's take all of the questions towards the end. It will be easier. And if you ever want to present at one of our meetups, you're more than welcome to. So please get in touch with us. We'll be happy to have you talk. And that's it for me. Take it from here, Alessandro.
Thank you, Dalia. So hello everyone and welcome to this meetup. So let me present myself. I'm Alessandro and I'm part of the services team in Elastic, where I take care of education, so delivering trainings for our customers mainly, and also I'm in charge of delivering consulting missions to our customers for ensuring their success with the usage of Elastic. So here today, I'm going to talk about the usage of time series data in Elastic and the management of this data with the feature named Index Lifecycle Management, or also with acronym ILM. So let's start with a presentation. And before getting into the details of the ILM, let's first introduce the time series data, okay? Because maybe you are already working with this kind of data if you have a project running on Elastic, but you don't really know it. So we refer to time series data normally to that kind of data that represents an event on a specific point in time. So for instance, if you are working with logs coming from your servers, or if you collect metrics from your infrastructures, rather than maybe collecting social media streams or any time-based events, these kind of events in Elastic are referred to as time series data. So normally an event that is composed of data plus a timestamp that defines the moment in time when this data was generated. Normally, time series data are used for search use cases. So for instance, you are collecting metrics from your different servers in your infrastructure. And what you want to do is maybe building up visualizations or fancy dashboards to visualize how your infrastructure is doing. And you normally search on recent events. So you can maybe check the status of your infrastructure during the last 15 minutes or during the last hour. But let's say that as the time passes, these information lose importance. So maybe you're not interested anymore in knowing how your infrastructure was doing 1 week ago, for instance. So when we manage time series data, the normal best options is to try to index this data in Elastic in dedicated indexes, maybe trying to collect data for a specific day or trying to collect data for a specific week, a month, a year, and so on and so forth. So when we talk about time series data, there are normally two challenges associated with the management of time series data. First, the first challenge is the data validity. So as I said, the data loses importance over time because older data is definitely queried less frequently, if not even queried anymore. So the first question that we can ask ourselves is, can we optimize the storage unit of my cluster in order to properly manage the indexing and the storage of this data? And then the second challenge is the control of how the index grows. So the problem with time series data is that if we think about maybe logs coming from a firewall, today we can have a certain amount of logs coming from our firewall, maybe 1,000 logs per second. But tomorrow, after maybe a specific breach or maybe an audit, our firewall starts generating 10,000 logs per second. So the amount of logs that end up in our index grows really a lot. And so we cannot really know and foresee the index size from one day to another or from 1 minute to another. So is there a way to control the size of an index in order also to properly dedicate the space on our cluster? Well, we are trying to address these two main challenges in this presentation, starting with the, first of all, index size management. And I just want to present visually this situation. So as very simple usage of time series data would be an application that you can see here in this slide that writes to a single index. So as this index receives logs, this index starts growing. Okay, so we move from kilobyte to megabyte to gigabyte and bigger size. And there is normally a degradation of performances in for instance, searches or management of the indexes in the cluster, depending on the size of the index itself. And so that's why we need to take care of how the index grows along the time. So how do we handle this index growth? Well, for this presentation, I wanted to also introduce you with a new feature that was included into the 7.9 release of Elastic. That's also a GA release. So definitely this feature is going to be kept for the future. And this is data stream feature. So data stream is an element that has been designed for giving you the best flexibility for indexing and searching data into your cluster. So it permits to provide to define an element that's named data stream, and you can configure your application to write using this element and also perform search requests of your data using the same element. If you ever work with aliases in Elastic, you may know a little bit how this works. So this works pretty much like aliases, but introduces some good advantages that I'm going to show you in the next slide. So the advantage here is that what we do is defining an element named data stream. So, and on the background, ElasticSearch takes care of the management of all the indexes that contain the data that we send to these elements. The idea is that data stream creates so-called baking indexes that is going to store data for an amount of time that is defined by a rollover policy. And we're going to talk about rollover policy in a minute. So the data stream can allow for the search over all the indexes that he manages. And also it takes care of indexing while defining properly the index where to write this data. So it takes care really of moving, let's say, the internal alias from one index to another without asking you to do anything. So the management of the data with data stream is simplified with respect to an alias. And so if we use data stream with rollover API, for instance, what we can do is define a set of rules that can be associated to the data stream. And for instance, say that every time the baking index where data is written from the data stream reaches a certain amount of a certain size, or contains a certain amount of documents, or for instance is aged more than maybe 1 week or 1 month, then the data stream will roll over, will create a new baking index where the new data is going to be written, and the old index is going to be kept in the cluster under data stream for searches purposes. Okay, so we will see in a demo later on how this can be achieved in one very simple command. And then the other challenge that we had to face was, how do we control the resource allocation? So how can we optimize the storage of our cluster in order to properly maybe put the indexes and their data on the nodes that can better handle our use cases. So the idea here is to define a so-called hot, warm, cold architecture. You may have heard about this already if you have read blogs about Elastic. If you maybe are using already Elastic, you may have found this in the documentation, because that's normally what we suggest to our customers when they need to handle time series data with a proper storage infrastructure. So that's the naming of this is just a convention. The idea is to define different nodes in our cluster that can support certain indexes for certain specific use cases. For instance, we can define in our cluster certain nodes that we're going to tag as hot nodes that support the indexing of the new documents that are coming from our logging applications, for instance. So all our new logs, maybe from the last day, are written into indexes that are kept into hot nodes. Then we can define nodes that we will tag as warm nodes that maybe will contain the older indexes that are not written anymore, but that are kept there for retention or just because they need to be anyway searched but less frequently. And then finally, we can define other nodes that are tagged as cold nodes. And these nodes normally needs to be used for keeping the indexes for a long retention time, but we don't want at the same time that these indexes uses a lot of resources on this node. We don't want this to impact on the cluster performances. And so that's why we can store their indexes that we call frozen, because their impact on the resources of the cluster is going to be really, really limited. And then maybe we can define a deletion time after which the index is completely removed from the cluster. So to enter better in the details of this architecture, so I said we normally define hot nodes, those nodes that are receiving the newly generated logs from our applications. So those nodes that really perform the indexing of the data. And as the indexing is a CPU and IO intensive operation, those nodes should be the powerful servers in your cluster. So normally the cluster where you have the largest number of cores, the highest RAM value, as well as maybe performant disk like SSD disk for improved disk IO performances. And then, so what happens is that after that, these indexes lose importance. Maybe this index becomes old. It can be moved from the hot nodes to a warm nodes, a nodes that can still be used for searching over the indexes, but that can be less performant because we first of all stopped indexing over these nodes. And second, we are querying less frequently. Maybe instead of performing a query every minute, we're going to query just every once per day, okay, or even less. So we just want to maybe store a large amount of data in these nodes that is used less frequently. And then finally, we can define nodes that we can tag as cold nodes that instead will keep the indexes for the longer retention period. And those nodes normally can be also maybe spare machines that you have in your rack that you didn't know anymore what to use for. So you can put on a reliable disk and just use them for longer retention period. So we can combine the usage of data streams associated to a rollover API for determining the creation of new index every certain amount of time or every certain disk usage, and the usage of a hot-warm architecture with a feature that is named Index Lifecycle Management. Okay, so this feature simplifies the management of the time-based data by managing the life cycle of these indexes from the moment of creation till the moment of deletion, moving from hot to warm and eventually to cold phases. So for this feature, we have a dedicated Kibana interface. So you don't need to know the exact code to use these with REST APIs, but anyway, you still have a dedicated REST API for configuring these. But normally, most of the customers, most of the regular users go for the Kibana interface because that's definitely easier to be managed. So the ILM permits to define 4 phases. For each phase, we can have a dedicated or more actions that can be associated. So normally, you don't have to define all the phases. For instance, you can have just a couple of phases, but by default, at least hot phase needs to be enabled. And I'm going to show you this in the demo. And then different operations can be done for each phase, like rollover operation, or like changing the number of replicas to improve read performances, or for instance, reducing the number of primary shards to reduce the footprint of the index on our cluster. Okay, so you can see here an example of different options that can be combined. And also the fact that you can have some phases enabled and some phases that is not enabled. So a dedicated Kibana user interface for doing this. And so what are the steps to define a ELM policy? Well, there are 4 main steps that we're going to see together in my demo. First of all, we need to create a lifecycle policy that defines the different phases and the action for each phase. And then we're going to create an index template that defines some settings that needs to be applied for every newly created data stream. So this template is mandatory for associating the new indexes of the data stream to the policy that we just created. And then we create the data stream that is going to hold all the data that we're going to index. And then what we just have to do is grab a popcorn box and start seeing our data entering into the cluster and flowing the life cycle as defined by the ILM policy. Okay, so here is my demo environment. So I'm going to give you some context to my presentation. So I'm going to use a cluster that I run locally with 5 nodes. And I have configured each of these nodes with a different property. So I have 2 hot nodes and 3 warm nodes. The definition of hot and warm is simply obtained by the configuration of parameters that you define in the nodes settings for your cluster nodes, and using the name hot rather than the name test or another name is completely a convention. Okay, so I name hot to stay with the convention of the architecture naming, but you can name the node as you want. So I have 5 nodes in total, 2 hot nodes and 3 warm nodes. And then I start sending data to a specific data stream And what I will see is that when the data stream creates the first index, this index is going to be associated to the hot words that will that will stay in the hot phase as specified by the ILM policy. And I have defined a rollover settings for which after 5 documents, my index is going to roll over. So the data stream will create a new index where to store the newly created logs. And so we will see that, for instance, when the rollover happens, so my first index is going to be moved to the warm nodes as specified in the warm phase. And then the newly index is going to then be kept in the hot nodes and will receive the new logs. And then what I did, it was also defining a shrink rule. The shrink rule permits to reduce the number of shards and modify in general the number of shards for your index in order to impact differently on your cluster performances, or to optimize the index, for instance, for reading operations if you increase the number of replicas. And I'd also define a deletion policy. So after 3 minutes from creation of the index, this index is going to be completely removed from the cluster. So you can see fully the entire life cycle of the index from the moment of creation till the moment of removing this index from the cluster. Okay, so let's jump on my environment and let's see this in action. All right, so I hope you can still see my Kibana. So now here I have my local cluster. So what I did was already providing here some command to be run for this demo. So what I did in advance was creating a lifecycle policy. So if you go into the stack management, I'm running here the latest, not the very latest, but the latest major release of Elastic 7.9. Now 7.9.3 is out if you're interested. So I can go into the lifecycle, index lifecycle policies. And here, this is the section where you can configure your index lifecycle policies. So for doing this, I created a policy that I called meetup ELM. And in this, I defined a hot phase. So in the hot phase, I configured, I enabled the rollover. So this will allow me for controlling the index size, okay? Because I want to make sure that the index is never bigger than 1 gigabyte, and also never contains more than 5 documents, or for instance, is never older than 30 days. When at least one of these situations match, then the data stream is going to create a new index where to store the new data. Okay, that's done automatically. Then I define a warm phase. In the warm phase, I said, hey, when the index is rolled over, so a new index is created, the older index is going to be moved to this phase. And in this phase, what I'm going to do is associate this index, so move all the shards of this index to our nodes, or multiple nodes that I configure as warm node. So I can define here the nodes by selecting the right attribute. So this attribute is the one that I configured in the nodes settings, as I mentioned before. So I have a settings named temp, and I'm going to associate this to nodes that have these settings equal to warm. Okay, and I can see from here that there are 3 nodes marked as warm nodes: node 3, node 4, and node 5. Also, what I'm going to do here is increasing the number of replicas per each primary. These tactics, let's say, is mostly used when you want to improve the usage of the index for reading purposes. Increasing the number of replica is basically related to increasing the reading throughput from your index. So the idea is that if you have, for instance, in this case, at least 2 nodes available, actually it's 3 nodes because you need to count also the primary shards. So if you have, let's say, a certain amount of nodes available, you can increase the number of replica, and each shard replica is going to be put on a separate node, and so you can parallelize your request over multiple nodes and make this faster. At the same time, I define a shrink settings. With the shrink settings, I can reduce the number of primary shards. And this is because primary shards are instead mainly used for indexing operations. So primary shards is the shard that always receives the new logs, and then it copies to each replica. So if you don't index anymore over this index, then what you can do is reduce the number of primary shards to the minimum number, that is 1, and so reducing, in this case, the footprint of this index on the cluster, because each shard obviously uses an amount of disk space and an amount of memory as well. So you want to reduce the usage of these resources from your index. And then I define a delete phase, and in delete phase, what I'm gonna say is, after the rollover of the index, please remove, after 3 minutes from rollover, please remove this index from my system. So I don't wanna see this anymore in the cluster, because maybe I don't really need this. And this can be easily a retention policy, where, for instance, you can increase this to 90 days, for instance, instead of 3 minutes, okay? If you wanna have 3 months of retention. Now, next step is to define a template that can associate every new index to the policy that I've just created, as well as the nodes that are tagged as hot. So here, first of all, I want to show you there is an API to verify the configuration of my ELM policy. So I can get here the settings of my meetup ELM policy, as I just showed you in the user interface. And then I define an index template that I name index meetup. This template needs to contain an index pattern. Index pattern needs to match the name of the data stream that you want to use. And then for using data stream, you need to define an empty data stream section in your index template configuration, because this then basically permits to use the data stream with this template. And then I can define some settings for each newly created index, like, for instance, having 2 primary shards per index, and associate every new index to this policy, and also put every new index on nodes that are tagged as hot nodes. Okay, so that's my settings here. And then the next step is creating the data stream with a simple command like this. So I get an acknowledge true, so I can quickly go and check that my data stream is rightly created. So I can go and check, first of all, the shards distribution for my index. So I can see that, so I can show you also in another way. So here I can get the information about my data stream. So my data stream named demo meetup, it contains for the moment 1 baking index, okay? The point ds demo meetup 001. Okay, this name is automatically created by the data stream. You don't need to do anything about that. And that's the real advantage of data stream. No need to define a rollover pattern for ELM as you would do with aliases in the back in time, just before release 7.9. And so here I can see that this index has been rightly associated only on nodes 1 and node 2. So these are my two nodes that are marked as hot nodes. And so I can start sending logs to my index. So for sending logs, in this case, I'm just sending a fake log, a really, really fake log with 3 attributes. And for interfacing with Elasticsearch, I use the data stream name, okay? I don't need to recall this name, because this name anyway is gonna change, as we will see. I just need to use the data stream name. So I can start sending a log, and I see that this is rightly stored into this index, and I can search over the entire index of the data stream by using a search API request and specifying the name of the data stream in the request. Okay, so I can see here, so I can obtain my document that I just sent. And so now I can start sending another document, and another one, and another one, another again. So we should get now 5 documents, right? Yeah, so we're at 5. So now, when we are at 5 documents, what happens here is that there is, let's say, a cron job, let's say like this, that periodically checks the status of the index and try to see if in the rollover settings that we just specified, any of the condition of the rollover settings matches over this index. We would expect that as we have 5 documents on the index, now the data stream will be able to create a new index. So roll over a new index where to store the new data. So let's see if this is the case. Okay, still not the case. Sometimes it takes more time. So we can wait a little bit longer. And in the same time, I can also check the status of my policy here. So I see rightly that I have 1 index of my data stream. This is still in the hot phase. And the next action is going to be a rollover. Okay, so it's going to be wait to be rolled over. So I can wait a little bit longer. Sometimes it takes more time than expected. You can define this so-called poll interval to basically define on how long you're going to wait before checking the rollover conditions. So let's wait here. Okay, it's taking longer than expected. Just want to make sure that I have reached the maximum number of documents. Yeah. So in the meanwhile, while we wait, I can answer quickly your questions that I see in the chat. So Stefano asked, what do you mean with relocate indexes? I mean moving all the shards of this index to a specific node or to a specific group of nodes. Okay, and that's what we do with the policy definition when we decide, for instance, to move all the shards of this index to nodes that are marked as warm nodes. Okay, that's what I mean. So really moving all the content of this index that is split into shards over a specific node. Then we don't need a license for ILM. This comes with a basic license of Elasticsearch. Okay, so you don't even have to have, for instance, Elasticsearch security enabled. You can create an Elasticsearch cluster and immediately right after launch your ILM. And then is data stream name something like a project ID? I don't know what you refer with project ID here, but this name can be whatever You mean, so the name of the data stream here can be whatever you want, okay? And then, so the data stream creates internally a baking index, okay? So the name of the index is just containing the name of the data stream, and then some internal name, so point ds, that means ds stands for data stream, and then this 000, a number, indicates the rollover pattern. So here, as you can see now, if I start indexing documents, what I see is that I now sent this document to a new index, right? So I have an index now that contains a document that is the index 002. So if I start searching over this data stream, now I get the documents that were stored in my previous index that, as you can see, just changed the name. It became a shrink dash the baking index name, and that's because this index now is in a warm phase, and in a warm phase we decided to shrink the index to reduce the number of primary shards. And this basically consists of creating a new index with a reduced number of shards. So from here we have a different name, but also we find the documents from the newly created index here. You see the demo meetup 002. So if I check my policy here, I see that my policy contains two indexes, the demo meetup 002 that now is in a hot phase, and then the shrink index that is in a warm phase. And the next phase is going to be the delete. So if I wait at least 3 minutes, I'm going to see this index disappear from the system. So let me start indexing other documents, because I want to show you that as long as we reach a new ILM rollover condition, okay, here. So I should see that a new baking index is created. So I'm just going to wait a little bit. But now, just want to show you something. So I just want to show you that the shrink index has disappeared. And that's because the 3 minutes since rollover have elapsed now. And so this index is finally deleted from the system. So when I say deleted, I mean you won't be able to recover those documents anymore, okay? So when you put some index in delete phase, remember, it's really something that is going to disappear. So either you have then a backup snapshot in place to anyway keep this data for a safe retention for the very future, or otherwise you will lose this forever. And now, when the condition will meet again, I'm going to see that now, if I check here, so I have 10 documents, I'm going to see that a new baking index is created, correct, here. So basically now I'm again with a situation where I have two indexes. The new one where the new data is going to be written to, and the oldest one that is going to be still available for search, right, here. I still see this as available for search. And this is going to be soon be moved to a shrink index. That's right. And that's how you manage entirely a life cycle of an index, okay? So normally with a real situation, let's say in the customer environment, what happens is that we try, for instance, to give some guideline in the size of an index. Normally for logging use cases, we recommend to keep a shard size between 10 to 40 gigabytes, because that's probably the best size to keep for having better usage of performances, better usage of resources from your nodes. Very small shards don't behave better than larger shards, especially if you have a lot of shards in the system. And also keeping a reduced number of indexes will allow you again for a better usage of resources, because there is also a rule for which normally we should keep the number of shards per node equal to a formula that tells that you shouldn't exceed the 20 shards number per gigabyte of heap space. Okay, so those are generally the guidelines that we suggest in consulting, but also during the trainings, if you want to manage your indexes. And that's why ILM and rollover, as well as data stream, can help you managing these and facilitate the management of your indexes. Okay, let's check the questions. I see a question from Parash. Okay, so a good question, Parash. So basically, when you manage data streams, as you can see from here, so each data stream contains a set of baking indexes, okay? So you can still access to the specific index by specifying the name of the baking index, like in this case, the point DS demo meetup. Now, unfortunately, or I would say this is how the feature works, you cannot define this name. So you cannot specify, for instance, here, a specific date that relates to rollover. But what you know is that every document needs to have a timestamp field that determines the moment of creation for this event. So I would rather solve your issue, Parash, or your request during using the data stream for the search, so demo meetup. But then when you provide your search, what you can do is specifying a query. And in this query, what you do is use a range type of query over the timestamp field. And from here, maybe you can specify a specific range. Okay, so this range can be, for instance, using the date math, anything from the last day, for instance. Okay, something like this. Okay, I don't know why it doesn't search here, but you can use a query with a timestamp. And that's allow you to define with this timestamp then the range of interval where you want to search your data. Okay. And then I see another question from Stefano. So these data, these indexes are not system indexes. They use a notation like system indexes, okay? But those are definitely user indexes, okay? Because those are associated with the data stream. I know they use the notation of system indexes starting with a dot, but those are user indexes, okay? So you have then fully control on them. You're welcome, and thanks for asking. So just another question from Parash. When we have 50 indexes assigned to a data stream, the query fires on all the indexes, which impacts the search queue size. Won't that create performance implications? Let's say that the performance implications not really depends on the number of indexes over which you search on, but rather than obviously the size of these indexes, right? The number of documents over these indexes. So definitely, depending on the type of query you perform, so what kind of research you do, there is going to be a different impact on performances. And that's why then there is also, let's say, a way to tune better the query, like for instance, introducing maybe the use of filters to make use of cached results, or specify maybe a certain time range for reducing the scope of the query, and so on and so forth. Okay, so obviously this discussion requires more details, but that's how I would definitely go for. Okay, so that was all for me in terms of presentation. And I just saw a question at the beginning from Stefan, I guess, if this slide is going to be shared. So I think this is a question for Dalia. I don't know if we can share it or not.
Exactly. So this meetup is recorded and it will be uploaded on our YouTube channel. I will post the link in the chat so you can find the recording there. And also the slides will be on the event page, uploaded, the event page that you RSVP'd on.
Super. Thank you, Dalia.
And just one last thing, if you guys can take just 2 seconds to fill out our survey, just to tell us if you like the meetup and what topics do you want to hear in the future, and then it'll be easier for us to see what kind of topics we can schedule in the future. I would just paste it in the chat right now. If you can please take 10 seconds, will be greatly appreciated. Thank you, guys.
Okay, perfect. So, well, I also want to thank you everyone for participating, and maybe I'm going to meet you in some training or consulting mission. So,
much,
have a nice night, everyone.
Thank you, everyone. Have an amazing evening and hope to see you again at our meetups.